In the course pack, we've combined sections 4.2 and 4.3 into one section, but these two sections deal with the substitution and addition methods for solving a system of linear equations. Section 4.2 is about substitution. We're going to talk about that method first. Okay, so the idea behind the substitution method is that if I have two equations, and at least one of them is solved for one of the variables. For example, in this equation, y is equal to 4x plus 7. I can substitute the value of y in for the y in the other equation. So what this would look like is I'm going to rewrite the top equation as negative 3x plus 2y, but instead of writing the letter y, I'm going to write what y is equal to. It's equal to 4x plus 7. I'm substituting 4x plus 7 in for y in the first equation. This gives us an equation in all x, and I can solve this equation by first distributing. So I'm going to get negative 3x plus 2 times 4 is 8x, plus 2 times 7 is 14, equals 9. And then combining like terms, I'm going to get 5x plus 14 equals 9. And then we'll subtract that 14 from both sides. So I have 5x equals 9 minus 14 is negative 5. Divide both sides by 5. I get x equals negative 1. Okay, now I kind of wrote over the next directions here, but we're looking at a system of two variables, x and y. So now that I know the value of x, I'm going to plug that back in to either one of the original two equations to find y. This is my x value. I also need my y value. So I'm going to go ahead and use the second equation. So the second equation is y equals 4 times x. I just found that x was negative 1 plus 7. So y equals negative 4 plus 7, it's going to be 3. Okay? As we saw from the last section, the solution is going to be an ordered pair, so the ordered pair solution is the ordered pair negative 1, 3 for this problem. That's my answer. Alright. So the process is to start by solving one of the equations for a variable, and then by replacing the variable in the other equation with that expression, we get an equation that we can solve. Let's go ahead and look at the next example. In the next example here, the first equation starts off with x is equal to 5y minus 7. And if I replace the x in the second equation with that expression, I'm going to be able to solve for y. So I'm going to do a substitution here. Since I already know what x is equal to, I'm going to replace x with that value, 5y minus 7. Finish the equation, plus 3y equals negative 6. And we're going to solve. So I'm going to use the distributive property. It's going to be negative 20y plus 28 plus 3y equals negative 6. Combining our like terms, negative 20y plus 3y is negative 17y plus 28 equals negative 6. Then we're going to subtract that 28 from both sides. So it's going to be negative 17y equals, let's see, that's going to be negative 34. And then divide both sides by negative 17. So two negatives, it's going to become positive 2. So y equals positive 2. Now, since y is 2, I'm going to go back and use my original equations to figure out what the value of x is. Y is 2. I know that x is equal to 5y minus 7. So x is equal to 5 times 2 minus 7, or 10 minus 7, which is 3. So my answer here, my final answer to this question is the ordered pair 3, 2. So that would be my solution. Now you can check that solution by plugging the values into both equations and verifying both equations. Let's go on to the next page. Okay, so in the next example, and in the rules above, we can see that the first step is really getting one of the equations to have a variable solved for. Like in the last two equations, it had told us like x equals something or y equals something. This equation doesn't start that way, but that's not a problem because we can go ahead and solve for one of the variables. That's what we're going to do first. Now, when you're starting in that step, you're going to look at all of the different parts of the two equations. 2x, y, 5x, 3y. And you're going to try to find the easiest one to solve for. And I'd like to claim that this y right here is the easiest one to solve for because it has no coefficient. So that's what we're going to start with. We're going to take that top equation, 2x plus y equals 10. We're going to solve for this y because it has no coefficient. It's just a plain y. And it's going to be the easiest variable to solve for. Okay, so y equals negative 2x plus 10. It's important for us to remember that that came from the top equation. So when I go to plug this in for a y, I plug it into the bottom equation. If I use the same equation twice, I'm not going to get the correct solution. Okay, so when I plug it into the bottom equation, what I get is 5x plus 3 times y, replacing y with negative 2x plus 10. Equals 3. Okay, and we'll start solving it. We'll use the distributive property. 5x minus 6x plus 30 equals 3. 5x minus 6x is negative x plus 30 equals 3. So if I subtract 30 from both sides, I get negative x equals negative 27. My negatives aren't showing up very well right here, but then I get that x is equal to positive 27 if I divide both sides by that negative. Alright, now that I know what x is equal to, we need to find y. And so to find y, we can use any of the original equations or even the one that we made over here. Okay, the one that I made already has y solved for, so that will be the most convenient one to use. So I'm going to use y equals negative 2 times 27 plus 10. Okay, so negative 2 times 27 is negative 54 plus 10. So my y value is negative 44. So the solution to this equation is the ordered pair 27 comma negative 44. Now, when I get numbers like that, very large numbers, I wonder if maybe I made a mistake. So I might want to check this one. Let me check it. Okay, so when I check it, I'm going to plug those numbers into both of my equations. So the original two equations were 2x plus y equals 10. So let me write that down. 2x plus y equals 10. And the other one was 5x plus 3y equals 3. Alright, let's check the first one. 2 times x. Okay, so that's 2 times 27 plus y, so plus negative 44. Okay, let's see what that's equal to. 2 times 27 is 54, minus 44 is 10. Again, the pencil is just sticking a little bit right here, so I can't see very well. So this one is a yes, right? This one checks. Alright, and so we better make sure it works in both equations, otherwise we did something wrong somewhere. So let's check this one. So that's 5 times the x value of 27 plus 3 times the x value of negative 44. I'm going to use a calculator for this one. So I need 5 times 27 plus 3 times negative 44. It's equal to 3. And that's what I was trying to get. So this one also checks, and this is the correct answer. Okay. Now again, when you're checking, it is important to check in both equations. It's very possible that you could have made a mistake and found a point that was on one of your lines but wasn't the actual intersection, the point that lies on both lines. Okay. All right, let's go to the next question. All right, and we have one more to solve right here. This is an equation that has already told me what x is equal to, so we're just going to go ahead and plug that in for x right here. So we'll start off with 2x, x is 1 minus 4y, plus 10y equals 4. So 2 times 1 is 2, minus 2 times 4y is 8y, plus 10y equals 4. So that's 2 plus 2y equals 4. Subtract your 2 from both sides. We're going to come out here with 2y equals 2 and y equals 1. Alright, and again, that would be the best candidate. Since x is already solved for, I don't have to do any work here. I just say x is equal to 1 minus 4 times y. Y I just found out was 1. So x is equal to 1 minus 4, or negative 3. So my final answer here is the ordered pair negative 3, comma 1. Okay. Alright, in objective 2, I'm going to use substitution to identify a system with no solution or infinitely many solutions. Okay, so let's solve this one. Solving, it's going to start off in a very similar fashion. I'm going to look for the best variable to solve for. The coefficient here is 2, 4, 2, and 1. So that's the one I'm going to try to solve for. It's going to be the easiest variable to isolate because it doesn't have a coefficient. So we're going to subtract the 2x on both sides. And we know that y now is equal to negative 2x plus 5. Right. I'm going to plug that in for y in the other equation. Okay, so let's see what happens here. What I'm going to have now is 2 times y. Y is equal to 2x plus 5 equals 8 minus 4x. Let's keep going. Let's use the distributive property. Negative 4x plus 10 equals 8 minus 4x. And we need to get all of the x's on the same side of the equation. So since I have a negative 4x, I'm going to add this 4x to the other side. And that leaves me with 10 on this side equals, I had exactly negative 4x plus 4x leaves me with just the 8. Both of those add to 0x. I don't have any x left. I have a statement that says 10 equals 8. Now, as we know, 10 is not equal to 8, so this should be looking a little bit fishy right here. This is not a true statement, which means that the answer is no solution. Okay. This system has no solution. You can also infer from that, since there is no solution, that this is probably a case where I have two parallel lines, and you can verify that by finding their slopes. Okay. This right here is not true. There were no x's, and I was left with a statement that says that 10 is equal to 8, so the answer is no solution. Now, if we had a similar question where you got something that was true, that would have been the other type, which would have been infinitely many solutions. Oops.